Thing you're going to do, which will probably take you the whole of one lesson, is to sketch out the main features of the gargoyle. You're going to do this in pencil really lightly, so that after we go over it in pen and add the tone, we can rub it out and be left with just a pure pen image. When you're drawing the face, try and really look at the gargoyle that you are drawing, making sure you're getting the perspectives of the shapes right. This takes us way back to our first lesson when we were just looking at the thing we were drawing. That was to help us get better at doing our proportions. So try and use some of those skills today. So this is the end result of my gargoyle, just the outline of it. And now we're going to add pen to create the tone. It is completely up to you which mark making technique you want to do. So you can do cross hatching, stiffling like I'm doing, or scrumbling, but it's important that you just stick to one. So don't try and mix them. Don't do stiffling and cross hatching together. We want all the face or all the gargoyle done in one technique. So with us drawing in pen now and adding tone in pen, it's not going to be possible for us to rub out if we make a mistake. This means that you should start by adding the lighter tones first. So if you're doing stippling, do your dots further away from each other to show the lighter parts of your gargoyle's face, then go back over it and start to add your darker bits by adding some more dots and making them closer together. Please do not automatically go over your pencil lines in pen, creating harsh thick lines everywhere. What you should be doing, if that is where your line should be thick, you are going over it, like I'm going to use stippling as my example. So on some of my lines, I've gone right up to them and done lots of dots really close together. I have not gone over and just done a thick line across it.
Whatever our clockwise moment is will equal our anti-clockwise moment. So we're going to look at the clockwise moment now. Now the clockwise moment, okay, will be the moment caused by this force and the moment caused by this force, because they're both going to make this turn clockwise, okay? And we know, so we need the force of the at point M times the distance to point M, plus the girl's force, so the force of the girl times the distance to the girl. So let's substitute our values in here. 270 newtons times that distance there, 0.25. And we've got to add that to the other moment caused by the girl, which is 300 newtons times by her distance, which is 2. Okay, and end up with 667.5 newton meters. So we know that clockwise it's got 667.5. So to balance, we know that the anti-clockwise moment has to be equal to it, because that's our principle. So the anti-clockwise moment will equal the force of the boy times the distance to the boy, and that's the only moment on this side of the pivot, so that's the only one we need to figure out. So let's substitute in the values that we know. We know that the clockwise moment equals the anti-clockwise moment, so I've figured out the clockwise moment here, so I can substitute that value here, because we know it's balanced, so these two are going to be the same. We don't know the force of the boy, but we do know that he is at a distance of 1.5 meters from the pivot. Okay, I now need to get rid of this 1.5 here, so I'm going to divide both sides by 1.5. So I get 667.5 divided by 1.5 equals FB times 1.5 divided by 1.5. So I've divided both sides by 1.5. I mean, you might know how to do this quicker, but this is a foolproof way of figuring this out. So we know 1.5 divided by 1.5 is 1. So we get left with 66.7.5, 667.5 divided by 1.5 equals FB, because these two cancel each other out. We then do that calculation and we get 445. So we
describe what I'm doing. So what I'm trying to do is I've got a molecule here. This was a bit like the trial exam paper. It had a photograph of one of these molecules, and all it asked for you to do was to say what the formula was, and it told you that one of the black circles on it was a carbon atom. Okay, and then it said, I know this writes upside down, doesn't it? So if I do it like that,
wasn't it like CH2?
okay, so that's a carbon, but then look how many white ones there are. So if the white ones were hydrogen atoms, can you see how many there are? On that,
CH4.
there's 4 of them. So this would be 1C and H4. Okay, so it'd be CH4. Still not happy with that, can't we? Okay, so that's CH4. Now, don't worry too much about that. There's bonds holding the carbons to the hydrogens, and we've done loads on bonding, so you're okay with that. You just draw bonds as these lines, don't you, between the atoms. You draw all these lines, and they're the bonds. Now, to break a bond, it's quite sensible. If you're going to break this pen, I would have to supply some energy from my hands to snap it. Yeah, I would need energy. If you're going to break a lump of wood, you need some energy to put in to snap it, okay? And it's the same with chemicals. If I was going to break a bond, I have to use energy to pull it apart.